And we're recording. Okay. Nick, welcome back. How you doing? You have a packet, sir.
No, I was trying to get myself, but I can't find it.
Okay. There's an extra packet on that little stool right there. Potato, potato. All right. Yesterday we talked about scientific notation and what it meant. Okay? Now we're going to get a little bit of practice in doing some arithmetic with numbers that are expressed in scientific notation. Okay? So, let's get started on that. First of all, turn to, I think it's the third page. Example 2, letter A. For a pencil? Yes, sir. See, my reputation precedes me. We got a lot of erasers here.
Oh, I don't need one of those.
Oh, you need an eraser. Solid eraser game there. All right. So, if I have two numbers that I want to add together, let's go back a few years. If I wanted to add 2.78 plus 0.316, how do I do that? This is before the days of calculators in our educational history. Brandon, please. Thank you. How did we go about doing that? Before we got to use calculators.
Yeah.
We add, right? Because this thing tells me to add, right? One on top and one on the bottom. So I'm going to move this thing to the bottom, okay? So let's do that. Yes? Huh? Oh, we line up the decimal points. Good. All right, so let's do that. Let's line up. Let's do that. There we go. There we go, like that, right? And what goes over here on the far side of the 8, Andrew? What goes over here on the far side of the 8?
A zero.
A 0. Got it, for a placeholder. Very good. Yes, Taylor? This one? I'm just making numbers up. I was making numbers up right now. Give you an example. Bringing you back to like, what was this, 3rd or 4th grade type stuff? So we line up the decimal points, right? Now, and then we just add like we normally would. What about things that are written like this? What's the challenge there?
Potato, potato.
Because all the
Potato, potato. What do you mean by that, Brandon?
I don't know, I feel like if you just add 4.5 and 2.4 and then just add the exponents, that it would equal the same numbers if you...
Ooh. Let's use smaller exponents. Let's say this was 2.4 times 10 to the 3rd plus 4.5 times 10 to the 4th. Let's pretend, so they're off, the exponents are off by 1.
6.9 times 10 to the 7th.
Hold on, just hang with me. So the exponents are smaller, but they're changed by 1, just like before, right? How would we go about doing that? Well, let's convert these to regular numbers, right, Nick? So 2.4 times 10 to the 3rd. How many times do I move that decimal place? To the right, but how many times? 3 times. So it's 2, 4, 0, 0, right? 1, 2, 3. And then plus, and this one I moved the decimal place to the right 4 times. So that's 4, 5, 0, 0, 0. 45,000. And now I line up the decimal points, right? Which are both here and here. 2,400, 45,000. And I can do addition just like I normally would. Now, My exponents aren't 3 and 4 though, they're 20 and 21. Do I want to write out 19 zeros and 20 zeros after those numbers just to do that? You want to write out the numbers. Okay. All right. What's a way around this so I don't have to write out all those numbers?
Can't you add exponents or like exponents? Or
If I'm multiplying two numbers together with the same base and different exponents, I add the exponents. But I'm not multiplying here, I'm adding, right? So, good call, Nick. But there's something else I gotta do. Let me ask you this. Go ahead, Zach. Which one? Okay, which way? To the left, how many? Oh, okay. So if I move it to the left 1, then this would be 2.4 times 10 to the 21st, right? Or I'm sorry, not 2.4, 0.24 times 10 to the 21st, right? So I'm going to erase this stuff so I have room to write. So now I got 0.24 times 10 to the 21st. 0.24 times 10 to the 21st plus 4.5 times 10 to the 21st. I could have done it to either one. I could have made this 45 times 10 to the 20th, right? Could have done that. Absolutely. Good call, Nick. Now, what do? I can ignore, because these are the same, I can ignore them now. Line up the decimal points, add them, and then it's times 10 to the 21st. So it's 0.24 plus 4.5, and you add them up. This is 4.50, right? So it's 474 times 10 to the what? Times 10 to the 21st. Do we see how that's done? I can make an apple into an orange, or I can make an orange into an apple. And then I can add just like I normally would. Okay? Multiplication is easy. Easy. What do I mean by that?
you just add the exponents.
Well, yes. We're also going to use the commutative property of multiplication. What's the commutative property of multiplication mean? Who remembers the commutative property? Zach knows, but I want to see if someone else can get some game in. What do you think, Brett? You know what commutative means? What's fun? What's nice about multiplication that I use all the time? Bam! Andrew's got some multiplication game. Do we agree with that statement, Brett?
Yeah.
I don't care about what order I multiply it, right? So here, I got this funky thing written this way, right? But it literally means 7 times 10 to the minus 9. And then times 5 times 10 to the 5th. So I'm going to change the order of all those things, because it's just 4 things being multiplied together, right? I got 1 thing, 2 things, 3 things, 4 things, all being multiplied together, right now? So let's change the order. Let's do the 7 times the 5 first, and then we'll multiply that by 10 to the minus 9th times 10 to the 5th. Now, I'm going to do the associative property, which means I can just put in parentheses wherever I want them to be. Meaning, I can do these, and then I can do these, and then I can do the 2 together. Do you agree with that step, Jeff? Yeah, I don't have to do them all in a line, left to right. I can do these 2, and then these 2, and then multiply them together. So then, what is 7 times 5, Devin?
35.
35, right? And then I got this. Nick, you threw it out before, throw it out again. What do I do here? Add the exponents. So then I get 10 to the negative. Am I done yet? No, why, Sophie? I got to move the decimal point. What do I want this number to be between? I want that number to be between what two numbers? 1 and 10. This needs to be between 1 and 10. So I move the decimal place one place to the left. So then this becomes 3.5. What does that do to my exponent? -3. Good, John.
Good job.
So this is equal to 3.5 times 10 to the negative third power. Okay? Letter C is division. It's division, which is pretty much the same thing as multiplication. Let me ask you this. Can I rewrite this fraction like so? Can I do that? I'm multiplying a fraction by a fraction now, right? If I did this, if I multiplied this fraction by this fraction, wouldn't I simply get this? I'm just going backwards, right? We've multiplied fractions together before. Now I am just splitting them apart. No, well, you could. That's another way to do this. I think this way is a little easier, but we can go over that way as well, Nick. Now, I can do 1.2 divided by 3, which is what? .4, yeah. 0.4 times, and then 10 to the 15th divided by 10 to the 7th. What do I do with my exponents then? Subtract. So then I subtract the exponents. 15 minus 7 gets me 8. So then it's 10 to the 8th. Again, am I done? No, because this guy is not between what two numbers? Not between 1 and 10. So I got to make it so, right? Move the decimal place 1 point to the right. And I get what? What does that do to my... Yeah, what did I hear? 7. So this is 4 times 10 to the 7th. Are we seeing how those things work? All right. Good. Now you get to do some on your own. That's right. You're going to do... So, adding on to... Did you have a question, Trey? Okay. Adding on to the assignment from yesterday, which was exercises 1 through 6. Brandon? Exercises 1 through 6, right? Okay, adding on to that, we got exercise 9, A, B, and C. Nothing else on this page. And then on the back side, the problem set, we got number 1, C and G. Number 2,
9 through 9.
just 9, A, B, and C, not 10. 2, G and I, and 3A.
Can you scroll back up?
I can.
Wait a second. C.
C and G,
Yep. That's pretty
so 1, C and G, 2, G and I, and 3A. And that's everything, right? There we go. That is in addition to exercises 1 through 6 and 9. There's our assignment due for tomorrow.
Die. Yes, die.
Oh.